Here is a Portland branded super cool VN model D3080. This VN was sent over by the letter H for some damage control. If I recall correctly, he said that one of the windings in the motor got broken while he was working on it. I have repaired that before. It's a little tricky, but it can be done. So we're going to go ahead and assess that here, and then if this assessment goes easily and the problem is clear, then we'll attempt to repair in this video. If not, I'll do it tomorrow because it's already almost 9 o'clock. And this is a very advanced repair. This is not really something to do while tired. And there's some kind of a plastic chip. We'll see where that goes. It's a 4-blade unit, which is pretty unusual, at least for something like this. This is definitely in rough shape here. Yeah, a lot of cracking inside the motor housing, but fortunately it doesn't seem to matter because it looks like the guard is screwed directly into the motor where it's metal. Alright, so this is where that piece comes from. We can probably glue that back. This doesn't seem particularly brittle. I wonder why that broke. Maybe it's more brittle than it seems. Geez, it doesn't allow much airflow at all. Wow. Okay, so I don't know where the problem is, so we're going to have to do some inspection here, see if we can find out where the problem is. I just found where the problem is. Okay, assuming that's all that is busted, I think we can fix that. You know, in fact, most likely it's probably only one speed that's not working with the way that failed. So you can see, well, you can't see it because it's all blurry, but right here we have a wire that has broken. This wire right here is busted. So yeah, okay. Not fun, but I think we can fix it. And we gotta figure out, where did it break? I think it broke from right there. Yeah, that looks like it's the break. Okay, I think I can save this. It's going to be challenging, but I believe I can save it. Now, I'm suspecting that we have a secondary problem, which might be the reason why this broke in the first place, and that is that the screws might be stuck. There is evidence of trying to get this out by turning it into a common, which is a very good method for stuck screws that are stripped, but likely all the force is, forcing a screwdriver probably slipped and cut the winding. So let's see first off if we can get this open. I use the largest screwdriver I can. Oh, that's a little bit too big. Well, I'm assuming he already got this apart because that came out like it was nothing. Everything is very like sticky in here. And this looks like it's been arcing for a while. That's not cool. Maybe just grease. I don't know. It doesn't look too good. Did you hear a bell? Alright, so it looks like the stator is probably going to stick to the front part, which is not what we want. We got to get that stator out of there. Yeah, it's going to stick to the front part. Actually, you know what? That might be okay. It's not ideal. This is kind of funky. I've never seen anything like this before. It's like plastic tabs soldered onto the, or just melted or infused or whatever you call it, onto the oscillation mechanism, just as a way of holding it in place. And the soldering is really, really shoddy too. I'm wondering if it's going to be easiest to just cancel all that out and replace it with just regular wire ties. Oh, I suppose we could even redo it. Actually, there's no reason why we have to, replace it and change it to something else. But I've got to get the leads off of here so we can remove it. If the shell is stuck to the front, that's fine as long as I can get the back off. Yeah, this is a disaster waiting to happen. I'm going to leave one of these screws in until I get done with this, figuring out how we're going to take this off. So it's simple. It's red to red, black to black, green to green, and blue to blue. And then where these go on there I think is arbitrary. I don't think that matters. Alright, we're just going to snip it off. I don't see a reason to sit here and waste time trying to desolder that. It's very poor work anyways. What an odd way to put it together. That is really quite odd. Alright, so here's the winding leads free. Now, this is all from the switch. And now we have the white and the gray turns into the red. And that's our thermal fuse or thermal switch. No, that's a fuse. But that's out very far from the motor. I really find it hard to believe that that would really do much good unless, you know, prior to something really catastrophic happening. Interesting. I guess it's easy to replace at least. Can't discharge this because of that thing that's on there. Oh, this is soldered to there too. Alright. Why? That's not necessary. Should have been a clamp. Alright, now everything should be free. Okay. This is going to need a serious bearings service. This is all very sticky. Okay, we have gotten to the problem area where we need to do some work. And that just got grease all over my stinking table. Well, I should have seen that coming. Can't have anything nicer around here. Alright, this is going to be tricky. This is a very clean break. I'm surprised that it only grabbed, or whatever, I guess the screwdriver only grabbed one of the pieces, one strand. So we need to cut away this what do you call this here? And this has all been varnished, so it's very stiff. Alright, we've got our workspace opened up. Here's part A, and part B is not so loose. We have to proceed with lots of caution here. I don't think we're past the point of no return, but we can very easily get there if stuff goes wrong here. I wish I had like a blunt plastic edge to pull that up. A coil comb might work. This is not working. we need to cut it. I need to use something that will execute a decent amount of force. This wire is making a mess. Those wires actually should probably be replaced. I think that's the plasticizer breaking down on there, which makes this a hazard. Okay, that was what I needed. There's definitely some pretty serious nicks there. We can varnish over it, but if it nicked more than just the surface and actually, you know, got down to the wire and kind of meshed them together, that I can't fix. It's hard to say. It's going to be a very close call if we're going to be able to salvage this or not. Very close call. I can patch these two wires together, that's not a big deal. I just don't know if there's any residual damage there. Possible that that's not actually nicking and it's the varnish just was sloppy in that area. That could be also. There's a couple other parts that look a little bit like that. So maybe that's all it is. Wish I had a magnifying glass down here at this point in time. Alright, so here's the two wires that we have to deal with now. This is a little tricky because there's a varnish coating on these wires, which is why the whole thing doesn't just short out when it's sitting together like this. The problem is when there's the varnish coating on there, we also can't solder to it. So we have to get that coating off so we can patch it back up. I'm going to get the soldering iron out at this point because I think we're just going to go through all the way with this tonight. fine tip on there. So what I'm going to do is we're going to take a razor blade. Hopefully this is in the frame. I'm not watching the camera at all. I'm paying attention to this exclusively. And we're just going to scrape off the coating. You don't have to do it much. That is probably enough. Try a little bit on the other side. Because at this point we got to balance flexing this delicate wire and getting a good connection. We're not going to get a perfect connection. We don't need a perfect connection. We just need one that is enough to work. And we probably have that at this point. Oh, for heaven's sakes. As we take this coating off, it's going to turn from the silvery color to like a grayish color, more of a silver. Copper to silver is what we're looking for. Starting to see it a little bit. Okay, there you go. That should come up hopefully on the video well. You can see the end of it's clearly a silver color, and then it turns back to copper as you go down. That's what we was looking for. And on this one, we've got pretty much the same thing. Can't do too much with this wire, but the way it's positioned, if this breaks, we're done. So we're going to call it there. That should be enough to get some kind of continuity across there. Okay, so now we need to get a small piece of wire to jumper this across. I didn't plan that part out. Very small wire. I almost need like something stranded and just take a couple pieces out. Here we go. I will use this wire. Just going to take like a couple strands of this and we're going to use that. That's all we need. This is a dissimilar metal, which is not ideal, but let's face it, there's nothing ideal about this motor at this point in time. Okay, so what we're going to have to do now is we need to cover this because the solder drips onto the winding. That might be catastrophic, I'm not sure. Potentially. So let's just avoid that. And we're going to need to get some, we're going to have to use some shrink tubing in some capacity. It's going to be tough because we don't have a lot of space to work with. We need to be able to slide this over there and then get it over the other side as well, because I'm trying to think of the logic of how we should do this. If we stick it on this side first, we make this connection and then slide it over, versus do we stick it on this side first, make the connection, and then slide it over, which would give us more room to work with. I don't know. I don't have an answer for that. I need some tape. I don't want to use that tape. Here we go, we'll use this tape. Okay. Alright, let's begin. I need to get some water onto this ticker towel and then we can begin. Okay. So be sure that we have a good clean iron to start with. It's a little bit too hot. Okay, here we go. I'm going in to get this done, get this repaired. So what we're going to do is we're going to start by getting some solder onto our piece of wire and a rock. We'll go through and tin this piece of wire first, just to make it a little bit easier to work with. This is acting so stupid right now. This is dirty again. This needs to be cleaned. Don't want a dirty solder joint. That's not going to help us any. Okay, let's see if we can get at least one part of this wire connected without too much aggravation. What is wrong with this? The solder's not working properly. What the heck? This is not working properly. This is annoying. The solder is just straight up refusing to connect to anything here. I don't have any flux on hand at the moment. Usually I have much better results than this. I don't understand what the problem is here. Shoot. Okay, that's one part done. Now we gotta get the other side. And somehow I've gotta get this shrink tubing on there. I might have to cut it in half and then slip it on afterwards. Did that work? I feel like that might work if I cut this in half, you know, like this way, and then potentially, never done that before, but it might work. Because otherwise, trying to get this, I don't know if I can get enough on there where I need it to be. And that's why the piece of tape is there. Alright, not the best work I've ever done in terms of soldering. In fact, it's pretty far from it, but I think it'll work. I think I've got a decent connection on there now. So now I have to figure out how we're going to isolate that from the rest of the unit. Yeah, I think that was successful. I'm going to try to cut this down the middle and see if I can put it on and then shrink it. See what happens. Now this is taking no interest in this idea. Oh, I think I have something that will cut this. And this is why I like to have a million tools, because some of them you only use once a year, but they accomplish the task like nothing else could. Actually, I think I'm going to spray some varnish on there first before I do that. Let's go get some varnish. Normally I don't like to spray varnish in the house, but we'll have to make an exception this time because I'm trying to get that to move outside. Don't think that's a good idea right now. We don't have to spray much, just one concentrated area that we need to spray. Here we go. Spray off EL 600. This is the varnish that I use, and I get asked constantly in the videos when I show the product, what is it? Here it is. I show it every time, and I often even type it in the video box, but people don't like to collect information. People want information spoon-fed. Collect information. It's a good resource to be able to do that. Okay, so what I'm going to do is spray on some varnish. Does this require the shaking? Oh no. It may cause damage to organs through prolonged exposure. Well, that's why I usually do it outside. I don't know if it needs the shaking. I think it does need the shaking. That's it. That's all we got to do. Alright, now we have to try to slip this underneath there. And before that we got to figure out why the camera is not charging. There, now it's charging. I sprayed on some spray onto this tool. That's not ideal. How the heck am I going to get this on here? It closes too quickly. I want to isolate this from the rest of the windings because I don't know, if I scratch any other part of the insulation off, we can get a short, and then it's a rewind. So if we can avoid that, with soaping a little bit of this on there, I think it makes good sense to do. The only problem is I'm struggling immensely to get this on there. Okay, there we go. It's starting to go on now. That's like 90% where I want it. I didn't expect this to be a hard part. Technically that's okay the way it is. I'd like it to be over a little bit more, just to be on the safe side of things. But like this whole operation, we have to balance this being exactly where I'd like it versus the movement. I think we're going to have to leave it like that. Alright, so now we have to tie it down. Oh, that's cool. I just picked up the bag of tie wraps upside down and they all came out of the bag. Now, some people don't like using tie wraps on motor windings, and I understand the reasoning. It's valid. But these are electrical grade ties. They are high temperature rated, and this will likely work just fine for many, many years. I'm not happy with the way that's sitting in there. It needs to turn, because my concern is that when the motor heats up, I don't know if the motor would get hot enough for the shrink tubing to actually start shrinking, but if it does, we don't want it to come out from where it is and then stop insulating this repair properly. And technically it shouldn't short out even if this repair was to touch the windings directly, especially because I just put more varnish on there, but I would rather not take the chance if I don't have to. Alright, I want to say that this is repaired at this point. Pretty happy with the way that came out. Everything looks reasonably copacetic there. It really does look reasonable. Oh, rats. This is not going to shut, is it? Okay, that's fine. I'll just redo it in a different spot. You always need to take into consideration the positioning of where the tie wrap ends. And in this particular case, both of these are ending in a situation where the motor shells are not going to shut. So we'll just have to replace them with another one that's positioned better. It should have been more like this. I can't grab it because everything is getting very slimy from all the grease that's in this thing. These are some good cutters. I don't know where the heck these came from, but I like them. It's still going to be very close. Wow. This motor does not have a lot of room to work. Very, very close, but I think it'll be okay. Alright, let's see if it'll fit. Okay, now we got to do some reconnecting here. I really think that we should just use barrettes. I think that this whole, I guess I could do it for the sake of originality, but for the test I'm definitely just going to use some barrettes. Can't tell if this is grease or plasticizer. This wire feels terrible. I bet this is plasticizer. Okay, so we know that we need to put the white wire on here, and actually I did leave enough such that we can just rewire to this. Okay, let's go get some barrettes, and we'll also ohm it out, so we'll go get the multimeter as well. That is upstairs. I think that I am going to wash my hands because they're all slimy from that stinking grease. Working perfectly. And we're going to need 1, 2, 3, 4, 5, 6 morettes. Pretty small ones. Okay. I think so that these will work. Something over there. Probably a raccoon, a skunk, or an opossum. The opossums are good, those eat ticks. The skunk, I mean, other than the comedy, I really could do without. Okay, so we know that the red these wires are so gross. Where's the thing? I forgot one of them. The red has a thermal fuse in between, so that must be the high side, or the common, depending on how this is set up. Alright, so we know that the green goes to the green. And the blue goes to the blue. And the black goes to the black. And the white goes on the capacitor. And onto that a Moret might not go. No, most certainly not. And then the red, oh, hold on, there is a gray here as well. I think the gray that the gray went with the red onto the capacitor. Right, because it was this apparatus that went, this was on here and went to there, this went to there, so then the red and the gray and everything in the red has to also go onto this side of the capacitor. And I'm going to ohm this out to make sure that the readings are normal before we plug it in. So if it is wrong, we'll be able to tell. Alright, if it goes according to plan, we should power this on and we should get a normal operation again. I think chances are pretty good. Okay, so we should be getting open load because, or open line because it's off. That's reasonable. That's a reasonable reading. That's a little high. That's higher. I think good. I am very confident now that this is going to work. I think what I'm going to do is I'm going to I'm going to plug it into the soldering iron apparatus here, and I'll ramp up the voltage very slowly. This way, if something is wrong, we can potentially shut it off before sparks fly and do irreparable damage. But I really do think that we're going to be fine at this point. Here we go again with the cord being wrapped around the base. Okay, we're going to start on low first. Made some noise. It sure seemed like it was going to work. Okay, that sounds good. Well, actually it sounds bad, but that's just because of the controller. Alright, this was a success. Seems kind of weak. Let's check the power factor. Make sure the cap is still good. .97, that should be reasonable. That is reasonable, so the cap is probably fine. 0.99. 0.39 amps, 47 the watts. I guess it's working normally. It just seems kind of weak, but the bearings are also kind of gummed up, so maybe that's why. And that's like hardly moving. Yeah, the bearings are definitely stiff. Well, it runs. It's been repaired. I'm glad I was able to save it. This seems like kind of a rare piece.